Welcome to Summarize Science. Today, we are exploring a fascinating new development in the world of 3D computer vision called GlobalSplat. This technology allows for the transformation of standard photos into immersive digital worlds almost instantly. Creating 3D scenes from a series of photos is usually a very memory-intensive task for computers. Most current methods try to predict 3D data for every single pixel they see. Think of it like trying to build a Lego set where you have 10 times more bricks than you actually need, leading to massive file sizes and slow processing. The researchers behind GlobalSplat identified a major bottleneck in existing technology. As more photos of a scene are added to improve coverage, traditional systems just keep adding more and more data points. This redundancy makes the final 3D asset heavy and very difficult to use on standard mobile devices. GlobalSplat takes a different approach by using a philosophy called align first, decode later. Instead of building the 3D scene piece by piece from each individual photo, it first fuses all the images into a fixed set of global scene tokens. This allows the system to understand the whole room before it even begins to draw the 3D objects. These tokens act as a compact summary of the entire scene's geometry and appearance. The system uses a dual-branch encoder to process where things are and what they look like separately. This architectural split prevents the model from getting confused between surface textures and the actual shapes of objects. Because the number of these tokens is fixed, the complexity of the 3D model does not explode when more photos are added. This keeps the representation incredibly lean without sacrificing the final visual quality. It basically forces the computer to be smart about which details are actually important. The results are quite impressive, as GlobalSplat can generate a 3D scene in under 78 milliseconds. Even more surprising is the final footprint of the file. While some models require hundreds of megabytes, this one fits into a tiny 4 megabyte space. This efficiency is achieved by using only about 16,000 Gaussians, which are essentially the 3D brush strokes that make up the scene. Other methods often use millions of these strokes to achieve similar levels of detail. By keeping the count low, the 3D model runs much smoother on everyday hardware. In side-by-side visual comparisons, the model manages to capture fine details like window blinds and complex room layouts accurately. It avoids the blurry artifacts and structural distortions that often plague other compact systems. The scenes look sharp and remain consistent even as you move the virtual camera around. The system even works well on vast outdoor landscapes, proving it is robust across different environments. The researchers tested it on everything from interior real estate walkthroughs to aerial drone footage of coastlines. In every case, it maintained its speed and small file size. To recap, this new framework proves that high-quality 3D reconstructions do not require massive amounts of data. By focusing on global scene awareness first, the researchers achieved a 99% reduction in the number of primitives required. It manages to balance being lightweight with being visually sharp, which is a rare feat in this field. Looking to the future, this technology could be a massive step forward for virtual reality and augmented reality. It might soon be possible to capture and share immersive 3D environments that load instantly on a smartphone. As we move toward a more digital world, tools that make 3D content accessible and efficient will be more important than ever.